We're now going to move on to quadratic equations, which are second degree equations of the form ax squared plus bx plus c equaling 0, where the a, b, and c are numbers, they're real numbers. The procedure for solving quadratic equations is quite different than linear. With linear, it's easy through a series of inverse operations to get the x isolated. With quadratic equations, because you have an x squared and an x term, we can't follow the exact same procedure. So what we're going to do is we are going to take our equation and set it to 0. We're going to factor it. In other words, we're going to get everything as something multiplied by something. And then we're going to apply this idea called the zero principle, in which if we have two things which multiply to 0, so if we have our two factors, something times something equaling 0, it means that one of those two somethings would have to be 0. Either the first term would have to be 0 or the second term would have to be 0 in order for our result to be 0. So let's look at how we can apply this idea. Here is a typical quadratic equation. It's of the form ax squared plus bx plus c equaling 0. And the first step in our process is to set the equation equal to 0, which has already been done. All right. The second thing we do, because we can't easily isolate x because the x's are of two different types, x squared and x, what we do instead is we factor this polynomial through methods of factoring that we know how to do. So in this case, we have a trinomial. We will be looking for two numbers that multiply to negative 63 and add or subtract to negative 2. So that would be x minus 9, x plus 7 equaling 0. So what I've done is I've now transformed my equation into the product of two numbers. This number times this number is equal to 0. And remember, if two numbers multiply to 0, either this number must be 0 or this number must be 0. So that then allows us to break this equation into two pieces. X minus 9 must be 0, or x plus 7 must be 0. You'll notice what's happened is that through factoring, we've broken our quadratic equation down into two mini linear equations, which we can then easily solve. What number would make this 0? 9 would. And over here it would be negative 7. And we have two solutions for our quadratic equation. A quadratic equation typically has two solutions. It can't have any more than that. And we can check our solutions by substituting back into the original equation if we want. For example, 9 squared is 81. 2 times 9 is 18. 81 minus 18 would be 63. And 63 minus 63 would be 0. So we know that that works. Another quadratic equation, second degree. So we will set it to 0. You'll notice that I've chosen to move everything to the left side. It's usually easiest to keep your initial coefficient of x squared positive. It makes it much easier to factor. All right, I have no common factor, so I am going to try to factor this trinomial as a product of two binomials. I am looking for the two first terms to multiply to 5x squared. Well, that would be 5x and x. And I need two numbers that multiply to 18. Whole bunch of possibilities. Let me try something like 2 and 9. Those of you familiar with the vertical method of multiplication can use this to try your answers out. This cross product is 45 and 2. That doesn't add or subtract to negative 1. So 2 and 9 do not work. Let's try something else. Let's try 9 and 2. Cross product is 10, cross product is 9. 10 and 9 do add or subtract to negative 1. And we would need a negative involved, so that would mean that the negative 10 would have to have the negative, and the positive 9 would be up as such. So our factors would be 5x plus 9, x minus 2. We have our quadratic factored. We factor so that we can solve. Two numbers multiply to 0. which means that this factor is equal to 0 or this factor is equal to 0. Divide by 5. Our next example looks very simple and straightforward. X squared equals 4x. All right, now it would be tempting to divide both sides of the equation by x in order to get x equals 4. Okay, and in fact x equals 4 is a solution. You can check that by plugging it back in. 4 squared is 16, 4 times 4 is 16, so both sides are balanced. The problem is there's another answer that I don't get when I do the solving procedure that way. You'll notice that if you just think about it, by inspection, x equals 0 is also a solution because that would make 0 equal to 0. All right. You need to avoid dividing both sides of an equation by a variable because when you divide both sides by a variable, you need to remember that that variable might be 0. And when you divide by x, where x is 0, you've divided by 0, which we know we can't do. All right, so that is causing us to not get one of the answers that we should get when we solve this equation. All right, so let's apply what we're supposed to apply to a quadratic equation. To a quadratic equation, we are supposed to set it to 0. Okay, so let's bring the 4x over. Okay, now we're going to factor. This isn't trinomial factoring, this is greatest common factoring. X comes out, and that leaves us with x minus 4 equaling 0. We now have two numbers that multiply to 0. Either this term is 0, so either x is 0, or what number would make this 0? 4 would. You'll notice that we have both of our solutions showing up when we follow the correct procedure, which is to set it to 0 and factor it.